the fires have sort of subsided, right?
What's that?
The fires sort of go down a little bit. They can.
I hope so. We need some rain and some wind. I think in another direction.
Wind, I mean, other direction. Not
other
not
direction.
wind, yes.
Right. Yeah, it is. It is significant and scary. I was going home yesterday, and it was worse than it's been, and my eyes were just stinging.
That just smells of ashes. Like it smells barbecuing everywhere.
Yeah.
It's just one big barbecue.
Right. Okay. So, welcome to session number 9 on torsion. So, what you'll find on the website is maybe almost too many links, but I'll try to kind of explain where I think it might be useful to look, if that's okay. So in this session, in this kind of combined session, right, we're looking at 9 and 10, okay? And here's the video that was what I formerly called Torsion 2. I kind of reorganized things a little bit so that we could have a bookend on normal loading with the finite element analysis and the thermal strain and stress, which we covered at the end of our meeting yesterday. And now with that, something's shifted a little bit. So if you want to look at the slides, like what we have here, you can click on this one. When I say here, I mean here. Okay, so your kind of standard PowerPoint. If you're interested in following along in the video with what I use, then you might want to go to this PDF right here. This is Su2023. So that was the spring 2023, session number 9. And you'll see that they're more in the form of notebook notes. Now, I've also gone ahead and I've pasted those notes in our summer 2023 in-class and office hour notes, so they're right here if you want them. Okay, so if you open this one up and it comes up and you go down to session 9, okay, you'll be able to find them in this form as well. So there are a number of resources to kind of get you acclimated with what we're going to be covering in session 9 and session 10. Same guidelines apply if you want to look at session 10 as well. Okay, so what are we covering in session 9, at least from a technical perspective? Well, we actually will not, so session 9 is in the original format, it got to angle of twist, okay? But that will come in session 10 actually, but we will cover a bit about shear strain and a little bit about shear stress in a twisted bar. So what are we talking about when we think about shear strain and shear stress? Well, remember, normal stresses, they act to essentially elongate our elements, whereas the shear strains and shear stresses are going to be acting to cause a change in the shape and essentially cause a shift in the sides by some amount given by a gamma. So if we look here, what you see is that we have this gamma, which is this angle with a vertical dictated by some displacement. So the top face of this 2D element, okay, that is undergoing a shift by delta, and this angle, given using a small angle approximation, can be given by gamma xy equals delta over y. Okay, so maybe I'll use this one since it's a little bit less. How do you say? It's a little less boxy. All right, and for situations where you have the equivalent, or the, how do you say it, an analog of axial loading, all right, where we said sigma is equal to E epsilon, we can use a similar relationship where we have tau is equal to G times gamma. So G is what we call the shear modulus, and it is related with a linear expression, actually. So it's proportional to the elastic modulus, and you'll see an expression for that where that factor is dependent on the elastic modulus and the Poisson ratio. And this most simply can be described as a shear stress associated and a shear strain associated with twisting of a bar or twisting of a rod, as you see here. Now, you'll have a chance to kind of go through and listen to the recorded session and get some perspective on what we're talking about and how we get to shear strain and shear stress. Nonetheless, I'll just kind of give you a little bit of an overview of what we have here. So essentially we have a rod, okay, and this could be approximated as a rod, and I've got some loading with this rod, and it's twisting, and we kind of have an idea that we're not, when we twist a rod, okay, we twist something like this, we're not causing it to elongate. Well, what we're causing it to do is to twist, and we have some relative displacement between the ends. And so you can think, oh, that's analogous to the displacement that I have with an axial member that I'm stretching, right? I stretch the axial member, I have displacement, it's coming out, right? But in this case, it's angular rotation. And so instead of normal stresses and normal strains, we also have local shear strains and shear stresses. Okay, so one kind of picture that is from Crandall, Dahl, and Lardner, but I've kind of redrawn it here, that I like, depicts a portion of a shaft, and let's call this kind of a very thick disc. And then if we draw kind of two fictitious circles, all right, so this top circle has this point C on it, and then this bottom arc, which is part of our circle, has this point B on it. What's happening is we've been talking, so now if I look at my bar, I'm twisting like this, okay? So that C is moving to the right, and B is also moving to the right, okay? But there's some change. So imagine this is a disc in a rod, okay? Then C is moving to the right, B is moving to the right, but C moves to the right a little bit more with the torque applied, as you see here. See this? So this is a TZ, and that means torque in the Z direction, right? So right-hand rule, that's causing a twist like this, and it's causing us to have this original B going to B1, and it's causing C naught, all right, what we'll call over here the original C, moving to C naught prime, and then even further because there's relative twist, okay? And so that's that original C, that C naught goes to C1. And there's an angle between this new B1 or this C naught prime here, this B1 and C1, that is what we look at as the gamma. And that's the shear strain. Okay. Now, the length of this region right here, okay, this highlighted yellow, that can be given by rho d phi. All right, so what are we talking about? We're talking about rho, okay, which is the radius, okay, or the internal radius to a specified circle inside the disk, okay, and d phi is not this gamma angle, but it's how much it's in this, it's in that, it's against the center of the circle, all right, and it describes that angle in there. So that's d phi at z plus delta z. So this would be the z height, and then the delta z or dz is the vertical, okay, where that would be, the z would be down here, and then dz is up here, so then this is z plus delta z, or z plus dz. So now we have this rho d phi, and remember, if we go back to this picture, right, we had a little delta, okay, in here, and that's from this shift, and we have a gamma here, okay, and so now we can define a shear strain as this delta over this y distance. Same thing that we have here. We have a y distance, which now is dz, and we have a shift here. That length is given by rho d phi. That was the delta you saw before. And so now we can describe a shear strain, gamma, as rho d phi over dz. Okay. And this, if we think of, okay, what's locally happening, this d phi, this is what we would think of as an angle of twist. And if we think about gamma, this is showing that rho is multiplying the d phi dz, all right? And so gamma is proportional to rho, so the radius, how far you are from the middle. So if you're closer to the center of the circle, that means that your rho is going to be smaller, which means that your shear strain is going to be less. As you get to the outskirts of a disk that's being twisted, or a rod that's being twisted, and you get to the outer surfaces, right? So if you're inside, that rho is small, and so that shear strain, that local shear strain is small. But as you get to the outsides, okay, you will get a higher shear strain. Okay. So now if we have an expression for shear strain, we can think about how we relate that shear strain, okay, through a linear elastic model, all right, which is the tau equals g gamma, which we just talked about. And we can think about where not only the shear strain is a max at the outskirts of the cylinder, but also where the shear stress is a maximum. The shear stress is going to be a maximum at the outer surface. And if we want to relate, all right, that maximum shear stress to a local shear stress. So let's say we're not at the outer surface. We're actually at another location, okay, like maybe we're half the actual radius of the shaft. Rho is equal to c over 2 or something like that, okay? Then we're going to have a smaller shear stress, just like we have a smaller shear strain closer to the center. And then we can do something very clever. We can relate the torque, right? So this goes back to how we have a torque being applied to the cylinder, and that torque applied to the cylinder is what's causing the twist. It's what's causing the shear strain. It's what's causing the shear stress. We integrate the shear stress on this surface, okay? Because unlike a normal stress, which is acting out of the cylinder, the shear stress is acting along the face of the cylinder. So we have these shear stresses acting, and then we integrate them, and we can come up with what's called the torsion formula. And this relates the maximum shear stress, okay, to the torque that's being applied to twist the rod. And another quantity, which is the integral of rho squared dA. And this rho squared dA, this is what we call the polar moment of inertia. And we can think of the polar moment of inertia as essentially what does the geometry, it's purely a geometrical quantity, all right? So it's giving us an idea of how much resistance, right? So if J is really big, then you're going to have less shear stress, you're going to have less local shear strain as well, okay? So it's resisting the amount of torque that's being applied to the system, okay? And to do that, this calculation, this integral rho squared dA, you can see it here. We solve out in using the integral of rho squared dA, that's J, and that's equal to the polar moment of inertia. And so if we use polar coordinates, we can integrate appropriately to calculate out what the J is for a non-hollow, right, a solid circular shaft. This is just a dr, all right, we can do this integration. And we can also calculate it out for a hollow circular shaft, essentially by taking the difference between what would be a solid one and what would be another solid one, but inside and removed, okay? So that is kind of a basic overview of what you'll get as you watch the video, as you embark on the problems as well. All right. So we'll go ahead and let's stop there, and I'll let you all work on the problems in session 9, and then in a little bit we can also talk about what's going on in session 10, where we begin to introduce angled twist. All right. Any questions? No? All right. I understand that we have some classmates who are concerned about exams for an exam for another class. So I understand that. The assignment that would have been due today, right, is due tomorrow. And then the assignments that are due on Monday are still due on Monday. How's it going?
Pretty good.
Yeah? All right.
try the FEA on, so it's all works?
Yeah. So so that's a good question, Thomas. Yeah. So I think I used FEA on SolidWorks years ago, and we've used you can use FEA, actually even in FreeCAD. You can do it in I think it's incorporated into Inventor now too. Yeah. So for our class, we're doing it with an open source.
Yeah,
right? So it's free.
Yeah,
right? But yes, those are good useful tools for design, and they're commercially developed.
Yeah,
It's very user friendly.
Yeah.
So is it like, if I watch the video on like the Pre-Pro Max FEA, is that like translatable to software?
Yeah, so it is, and there are some software packages. So SolidWorks and some of these other companies that focus on CAD, they've kind of integrated a nice user-friendly thing.
Yeah.
But then in industry, right? I mean, I think there's a shift, right? But there used to be, like when I spent some time working with some aerospace people at NASA, and there's kind of the design group, and there's the analysis and verification group, right? And then so the design group does stuff, and they throw it over to the analysis group, and then they throw it back, right? But there's, like, even as we're seeing with software, right, there's more of an effort to kind of integrate some of these things together. Yeah. But yeah, so like CATIA, right? That one is like pretty much hardcore finite element. I use COMSOL. We use COMSOL a lot in our research group. That's kind of hardcore finite element. ANSYS, right? Also hardcore finite element. So what you're seeing is the models are typically built somewhere else, and they're brought into the finite element package. And they are more, how do you say it, detailed in a lot of reasons. Like there's a lot more. Because another thing with finite element is you want to do baby steps, right? So when we do stuff, one of the useful things of the analytical solutions that you'll see, right, in this class is that they are true and you can simulate them as a starter, okay? And so once your simulation matches these analytical results, then you can introduce complexity. But if you just go right to the complexity without doing the simple base cases or the verification models, maybe you just plug in the material property wrong, right? Or you plug in, or your units are wrong, right? Or your boundary conditions are wrong, or your force, right? There are all these things that can be wrong, or you don't have enough elements, right? So you have too few elements, and so it converges, but it converges to something that's not accurate. So you have to add more elements. So these are kind of the basic techniques that we're getting to cover here, and that you can take and then apply when you do more complex.
So is that common practice though in the field to like set that base case?
So I mean, if you're an experienced FEA person, then you may not do that. But but for our group, when it's like the first time they're doing FEA, it's like don't even try the hard stuff. Get the simple thing to work, and then we can move on to the harder stuff. But with simulation, you have people who like to do, like we live in a world where a lot of people consider themselves either an experimentalist, and other people consider themselves as either theoreticians or simulators, or simulation or physical modelers. We'll call it. They want to call it simulators, right? So sometimes these factions, in physics is a classic thing, right? I guess there's a new movie, right, about I imagine I don't know exactly what they're going to be covering, but I think you're going to see some people saying, well, there's this theoretical prediction, right? But based on the trailer, I was like, are we going to blow up the world? We don't know, right? So, it happens in mechanical engineering as well.
You say he's running.
How's it going?
It's going good.
All right.
He's running. I was like, wait, I know.
Oh, you're
Mars.
Give up. Then multiply by the
It's like, me and George are like.
And then the toughness was you add.
E-ring?
Yeah.
How's it going?
Grab the right
Okay, got you here.
And George is on his way home.
So,
I called him when I was leaving my house and saw like.
Oh my god, yeah.
Alright, well,
Maybe another.
I was up very late last night getting revamping things and trying to fix things.
So real estate.
We were up last night, so we did the homework.
Huh?
We were up
You were up
last
last,
Yeah.
well, that's good that you're doing it in head.
Yeah.
You know, my professor was like,
We did all the
so I'll never forget, like, this is,
Okay, good.
you know, so much, but it's.
So there's 9 and 10.
Yeah.
Professional calculus.
We have questions on the
There's
example
two.
exams on Tuesday. And the material that we covered today is it. Everything's Tuesday. So you got like 4 days, 5 days, 3 days, that's Friday,
Is this
Saturday,
the area, this area?
Sunday, Monday. Yeah, it's 4 days and then exams.
Some city.
Right, so that's yeah.
So like, yesterday at our bars, I was like safety line and stuff.
Yeah.
And like, when you safety guard, like, you have to twist the wire, like,
Or it's
all
add
in
one.
one without the other. And apparently that's
Wow,
like,
that's a total area.
like, the wire
And then
is,
you're-
it goes through stuff, like, why is that?
I didn't even know the basketball fine, 2 triangles.
So I'm not, to be honest, I'm not familiar with this. So what are you doing? You're doing, is this this is in case you have a rupture?
No, so it's, okay, you have
Or is
two
this
bolts.
our electric connection?
No, it's physical bolts, right?
Yeah.
You have 2 bolts, each of like this. You drill holes with them,
I
right?
don't know that much about it, like.
And you have like a long piece of wire,
I was trying to-
and take it, I can picture it.
Yeah, I'm not sure.
So I-
Matt, what's up?
Good morning, how are
Good
you?
morning.
Sorry I'm a little bit late today.
I understand.
2 minutes, never 2 minutes.
Did you really watch the basketball game last night? No.
I swear, I thought it was.
Okay, whatever. So you have, okay, so you have 2 bolts, some distance apart from each other.
They're usually pretty close.
Okay, pretty close.
But,
And then,
the other ones was you
with
were
the
very
wire
fast,
through.
like, basically 2
Okay, a wire through the head or a wire through?
Through the
It's
head.
taking a while to
Okay.
figure
It's
out
the
how
side.
to type it down.
And then, you have a
Even
wrap
like
around.
passes, it'll give you-
And then you do the same thing with the other bolt, and you have it in the direction so that when one bolt starts to untwist, it'll screw the other bolt in. And then the other bolt starts to untwist, it'll screw the bolt in. Like, you don't want like, cause like, if it's like going on a lot, like if it race farther along the vibration,
Yeah.
you want to like plug in and eventually snap the wire.
Yeah.
So what you do is, when
At least
it
now that
goes
I
through
know
one
what
bolt,
it
you
is.
twist
They're
it,
really good.
you keep twisting it all the way to the next bolt.
Oh,
And the reason for that is to stop it
well, I think,
Yeah, that's, I think.
this is, I haven't done this process myself, but this is my guess, right?
I was like, fuck.
Is that,
I was bad, like,
one, by twisting it, you can introduce,
I'm not professional, you
close
close
the
the
gap.
direct range.
right? So that it
Oh,
doesn't,
that's good, yeah, yeah. Like when you
Yeah,
run,
yeah,
you press only
yeah,
machine.
so that there's
I don't know,
minimal,
it's one thing.
minimal twisting or minimal agility of the screw to,
I'm so sad.
lose height. That's the first thing, so you got resolution in there. Cause, yeah, vibration, like you use lock height to try to mitigate vibration, and most cases, that's pretty good. And the other is, as you're twisting, right, what are you doing? You're increasing the effective cross-sectional area.
Oh, really?
Yeah, right, so, right, you like, as I twist and twist and twist, right, that, I started with a wire that had one cross-sectional area, but now it has this, significantly larger cross-sectional area. So as you do that, right, that means that you'll be able to handle more stress, or be able to, not more stress, more force, right? Because there's no, you'll yes, no, less stress for given, less stress for given force.
Okay.
So Tuesday,
Right.
then.
So,
So it's just,
yeah.
there was Mondays and stuff.
In DMC, when you take DMC, at least the way we've been teaching it,
Yeah, so
you'll
yesterday,
you
yeah.
look at things like, torque on bolts, right, and use those calculations, and plates and things of that nature. So, as you know, it's a big deal when the bolts are not torqued appropriately. But at least this will keep them from coming out. As soon as that retention is gone, right? Because what you want with, whenever you a substantial amount of pre.
Like it's helpful, but it's
Usually you know how
In the
to
plates that are being brought into each
Yeah,
other.
you know how
The
to
plates are participating.
solve for
If
determinants.
the force ends up being distributed just in the cross section of the
solving
bolt,
watching a 3-minute YouTube video.
The safety wire doesn't do anything in terms of pushing it. Like, if the bolt isn't tight,
Oh,
the
yeah.
safety wire won't do it.
Right.
Like, it doesn't actually add any extra tightness, it just keeps it from coming. That's the whole.
different cube,
That's the safety.
Yeah.
Safety wire. Okay, good, that was good, thanks for bringing that up. That's, so you do that, where do you do that on the car?
A lot of spots on the throttle pedal, on the brake calipers, the rear seat, has the motor, it's on a motor mount, on the bolts,
Yes.
so all those, a whole bunch of places on the car.
Brackets, the pedals.
Yeah.
The headrests.
From what I understand, it's
Okay, great.
Really?
Big. And you have special wire for that, special steel wire, or?
Yeah, it's just wire. We sold some too, it's
That's
some of my friends use steel.
Yeah.
They work at Marana. It's a defense company. There's a bunch of our alumni there.
That's,
So the alumni were just like, oh yeah, take as much safety wire as you can, so you guys have enough.
Alright.
Like they were on the team.
good.
Yeah.
Oh, and, you're gonna send me a note, right?
Yeah.
Okay.
I had.
Yes.
For this question,
Yeah.
where it's just a cube pressurized underwater, what's the change in?
Yeah.
So what does it change
And one side of the.
Like, we met on
one
our-
side?
Yeah.
Uh, Does this give us all the information we need, or do we have to assume
Well, we need to know
thing
something
of
about
polycarbonate?
polycarbonate. Yeah,
So is it just in the slides and I just take one of the numbers?
Yeah, so which number, yeah, I mean, you wanna get the bulk modulus, right?
Yeah, that's fine.
So,
It's, I think it's in the slides, I was
Yeah.
just wondering if I had to guess or,
no, well, I mean, you could also look it up, right?
yeah.
But here are the numbers if you want them.
Point.
Oh.
Yeah.
Yeah, same thing, so,
Okay.
yeah, 2.6.
Oh.
Okay, I was just wondering, cause, you know, everything. has-
But you have to relate it, right? You have to relate it, remember how you have to relate it, so if you go, well, actually, you can do it through here, if you want, right? You're gonna relate the K to this epsilon x. Which one is this? Yeah, I guess it's not available on Windows, right? Yeah, it's like iOS.
I'm at like 6 right
Steve Jobs proposed the 10, but yeah, the company has come up with solutions, or others have come up with solutions. Because the pen you can buy now from Apple, right?
Yeah.
What do they call it? Do they call it iPen?
Dude, I would be so.
Yeah, I'm a Surface person, but that notability looks cool.
Professor,
Yes.
can I use SolidWorks for the FBA?
No. No.
Okay.
Only for creating the I want the screenshots from the Freeform X. Even though I hadn't done it since last semester, so I forgot that one step, which I'll mess up, but yeah. We got resources, so we want to do Freeform X. It's an open source tool that you can use for the rest of your life.
Just because I've already done FBA on SolidWorks.
Where's the folder?
Tests. Old tests are on the website.
Oh.
So if you go to the website, George, good morning. So if you go, there you go. Exam 1.
Yeah.
Yeah, so exam it's like for the exam.
For that, are these exams for like the hour 20 period, right? So then it's gonna be like double. Well, no, not double. It's gonna be
So
just like.
I think we're gonna people. I think these exams are pretty intense,
Okay.
and a lot of people would have liked to have had more time.
Okay.
So
So
I
we'll just
don't-
keep it like this and.
they might be a little bit longer, but I think you guys are gonna have more of a luxury on the time. All right, that makes sense.
Yeah.
Yeah, they might be a little bit longer, but that's a relevant question.
Professor?
Yes.
I can download Pre-Pro Max on my laptop. Why not? It's a Mac.
Yeah. So then, that's,
I have a Windows on the front for the key.
well, you can also use the computer
Oh,
labs.
for that one's.
Yeah, because so if you go to computer labs, you just
Say
download
that.
it there.
When I did, I made that go.
Yeah, there's no, I agree, I don't have a good solution to that, but we do, since we do have the Windows.
I have a Windows laptop. I just versus.
Oh, okay.
0.05%. And that's the spring.
Well, then you can go on that later, you know, you don't wanna take, you don't take pictures or you use screenshot, right?
I'm going back down the same source of that, so.
Actually, you will have a different geometry. Okay.
But I don't know if I did that. You're right.
Yeah.
I mean, 0.095, that's every other one.
Or even, he can let you use your laptop.
Yeah, so you go 0.05 what to. So 0.15 minus 0.05. That over 100, I mean, that's your straight rate, which equals changing like that.
This picture is good. 15.
Minus 0.05, not 0.015. And then divide that by 0.15.
Out of nerdy humor, when I was creating these slides last spring, I was hungry, so I went to a certain pizza place on campus, and that's the pizza, right? And
That's what
I was like, that's really similar,
what is it?
right, to these diagrams, right, where you have a slice and this angle, right, of the pizza there, that would be our phi, right? So I need a bigger piece of pizza, I guess, for that table to get it to be in the middle, but you can see the analogy. That's your nerdiness.
Is that the Douglas Student Center?
No, that's here, right? That's here. That's the table. That's actually office. That's the office. Yeah, that's where we're. The pizza is not. The pizza is from Bush. The table is.
Grimaldi's?
Huh?
Grimaldi's?
Is it in the Student Center?
Yes.
Oh, Sparrows?
No. And it's
No,
from Bush.
Pizza.
The pizza is from Bush.
Oh, just the Bush diagram.
Just the Bush. Or,
Grimaldi's Student Center?
no.
Bush Student Center?
Where'd you get Bush Student Center?
Oh, so it's Sparrows.
No, that's
No,
not
that's
Libby.
where-
That's Libby.
Oh, wait, that's Livingston.
And also Grimaldi's.
Yeah, you're right.
Okay, well, I wasn't going to name them on YouTube, but they're Gerlando's. All right, that's Gerlando's.
Free advertising. Yep.
Not that anyone will ever watch this, but that's okay.
If not,
No, I'm not doing
you're
it. You're nested.
Oh, physics? Yeah. All right, yeah.
I'm guessing it's no.
Okay.
We're gonna have just like.
So feel free to like,
Oh, okay.
yeah, jump over to another, I mean, if you want some camaraderie.
Are you defending my students?
Dude, yeah, I did that a lot. And those were the shoot from
No, but if I
allow flagging, so like we can't do a loop, and like say like.
Oh,
sorry.
alright. Speaking of, how's it going, Michael?
Yeah, but he didn't allow that. How do you do that? Dude, that was forever to figure that out. I mean, unless you give them like if and no, you just have to do like 4 if statements to like satisfy. I would wish to like, you know, if that condition and have like extra variable like plus 1. You know, as long as the movements.
well, like, right now, I think he's probably gave me that. So I was like,
Any questions in this quadrant of the room?
It's a small piece. Like, you can burn the table. Like,
Yeah.
That's a big table, yeah.
True that too.
It's a long size.
Just go back.
It's a table, there are 4 chairs now.
Oh, it's a good size.
It's a, I mean, it's a, how much is it?
It's like your office in the engineering building?
Yeah, the old engineering building.
It makes more sense to
It's on syllabus.
Wait, is it by
It's
like,
by
you know the
the-
aerospace, I think you touched on the aerospace.
Yeah. He has like Demaro.
Tomorrow,
Yeah, or Professor Demaro.
Is it by the key?
So no, so we have, so our lab is actually very close to the cage and stuff, on the mezzanine, right? But, this is another portion of the cage, closer to what.
And then it's like halfway.
Any chance, is your lab the one with all like the nets and the?
That is not ours, that, lab,
I peek inside.
that's probably Shao Wise,
Interesting
lab.
things.
And also, I think maybe Javier Diaz has, Diaz might have some stuff in there. No, we don't have the nets.
Those are for like drones or something?
Well, and then also Professor Leon has nets. It's like if you're not in by the mezzanine, if you peek in there, you had to go in and around.
You're gonna also sort of bounce.
It might be a little bit longer, but I think you're gonna have the traffic.
I'm confused on like how you download the freeform maps.
Okay.
Like,
You
4 hours a day,
you
everything.
watch the video? I mean, that's not.
I couldn't find the video, like,
hit us with that.
You know,
Well, it's on the engineering content.
Oh, yeah, actually, I didn't say that like.
So if you go, go up.
Yeah, he's like.
Yeah, that-
Oh, this one?
Yeah, yeah,
Oh,
that's from yesterday.
Oh,
Yeah,
oh,
so
oh.
anything we do like as research,
Yeah,
it's
so,
really So I went into technology and like one thing he says is like
yeah, you can watch me bumble around for like 20 minutes.
Is this the maximum?
We have to
This is where that's.
You did too, right?
some poor McDonald's.
So if you will bring it back up. So this is
Getting the
the
rest of
review.
it to yourself.
Well,
They
so
can't.
let those
They
people,
won't
this
be
is,
connected.
this is an expression for the max, right? The maximum is at the middle. So where, you know, the way this is set up, right? You have X starts from the outside, and so as it goes to the bottom.
So bad.
We learned that today. Oh, yeah.
But it's only the equation.
So, yeah.
So see, X is starting here, from the outside all the way in. So at the middle, right, that's like where we were talking about yesterday, where all the gravity,
So,
for all the mass, right?
this whole equation,
After the time, y the gravity,
this thing
so
right
it's gonna
here,
be highest here.
solve for L.
At L over 2, you get over here, right? So you gotta
So
go down.
if that was like correct, like it gets that.
And if we're looking at halfway across,
That's
we're
the two
using
functions. So
this
it's
expression,
basically H is equal to.
right? think that's
H
just
plus, this is H plus, seems like real big problem. But it's, actually 6.6.
Yeah.
This is H bar, but pretty much for this, like, whatever I'm trying to do.
Well, first, we actually want to distribute force. So this is the stress.
Yeah.
Okay, so you have distributed force up there, right? Yeah. The next one is.
And then we put in the chat.
And internal, internal force, right? That's right. Okay, so you got that one, and then the next one is. Yeah, so maximum axial stress, so let me have to change it first, so it's not maximum axial stress, it's just axial stress.
Just like that.
Alright, let me change that, that's good, thank you for pointing that out, Jason.
Oh, E equals. Times 1 minus
Where is
C. Or equals to K. Wait, K is the ball line?
We park at the field.
Or is it, sorry, equals.
You need part of the
I
wall.
don't know, C over negative K.
No, that one doesn't give me like.
So what's the question?
Wait, K equals P over delta.
Yeah, K is duplicated, we have K, so we have it.
Yeah, we do.
Wait, so we just use K?
Is it, what's his name?
We know that really goes to, I don't know, 23%. See, it's a little bit nicer.
Yeah.
And then it'll go back up. So it'll probably either 0.2%.
Oh, no, that's for the strength constant. So,
That'll make this one go.
It just gives us 60. No, you got what's little you hope? Equals E change.
No, that's not true. No, don't get me wrong, it's still a lot. 543 versus 503, that's pretty big.
Oh, it's 23. Wait, the 2024 makes 440.
Wait, no, I think that's current driving.
There's no way.
No.
Most of you won't actually be in there because it's solved out like this. It's solved out, it's gotta that's just showing how you got that. But the change in length is in this P. Sorry. Which I don't think much.
No, I always get like just that.
I'm worried about
Just that.
No, these assistants are worth.
Yeah, next time.
It's like 20.
What is it?
Oh, that's
Feeling like that.
I don't know about that.
Like I wear like I wear doctors.
Yeah, exactly.
That curve better be
See, this
crazy.
one leaf.
This is small as class, so these kids actually know what the fuck they're doing.
So negative T.
Yeah, everybody knows what they're doing. He's looking up for curves, sure.
Okay, so negative
We gotta get a curve, okay?
Alright.
How's it going?
Sorry, I had an appointment with my cancer. So I wasn't in the next building.
What's atmosphere
Okay. Gotcha. Thanks for attendance.
Definitely no. Oh, well, just 119 said.
Man, just read us like a couple of days ago. They also made.
I thought you meant like just one. What about the whole one?
Yeah, but I'm not. The biggest point of MATLAB is matrix.
I only learned through matrix and calculus. Yeah, calculus, I really thought.
That's the ballpark.
Wait, session A is the last time this will be on the exam.
Wait, 2.6, do you get it?
You did chapter for session 9 and 10.
Huh?
You did session 9 and 10.
You are on session 9 and 10, yes.
You need to do
It's due on Monday because the exams on Tuesday.
okay.
Yes.
Okay, so, do you want to just give me what are your numbers?
Oh, last question. Are we gonna do anything on Monday?
Yeah. Yeah.
Session 11?
Yeah.
That's gonna be a
No.
no? Fine.
Yeah. Except the stuff we cover on Monday will not be due on Tuesday. It'll be due on Wednesday after the
Won't be
exam,
in detail.
and it will not be on the exam. Today is the last day of material that we're responsible for the exam on Monday.
Alright, perfect. Thank you.
I know that all these fractions.
And then also using book slides also.
You don't use X.
Oh, you don't use X. Triple, double, so it's like 6 columns.
And then sigma is summary for like what the Q and the pressure all can be the same. So it's like just doing sigma x. Yeah, which is also equal to, there's also equal to E. And so you can E is equal to sigma x equal to E.
Are you sure session 9 is not?
And then
Professor,
by definition.
What's that?
last thing on the first exam will be session 8,
So.
or session 9 on the.
Hold on, just okay. So I'm wrong, Jason.
Yeah.
I'm wrong. Okay. Yeah, it is. I did answer that. I gotta take out the x equals because that's confusing.
Yeah.
Okay.
Yeah, wait,
Yeah.
E is the volumetric.
Because I'm looking at what I did and what it, and I'm like, oh no. So I'm just gonna take out the x.
Yeah, yeah,
The x equals
So
2.
the same way that,
That's
the
actually
same
very
way
on
that
this
stressful. I'm trying to find it now. It's the same concept as normal strain, but instead of forcing the.
So what we just
Just derived it. It's PL over PL squared equals the G. It's the E, it's the forcing young bodies, cuts the pressure and then you just E related to the
Sounds great.
Sounds great. So A will GX.
He's coaching the account, so it's not a.
No, L comes when you do the integration. Because you do the integration from 0 to L. X. Yeah, and then so does the last one.
Once you do the integration, it just like the other class.
Well, it's not just integrate. You integrate. It's integral.
Okay, George, you had a question?
Yeah, session A is the last thing on the first exam.
No.
Session 2.
Wait, so we're doing 9 and 10 today.
Oh, 9, 10, both are systems.
Which are intense.
Wait, I'm pretty sure you just
Well, we can talk about things on Monday if you have questions.
Wait, so then the session that we're doing on Monday, is okay, it's not on the exam, right? But is that gonna be due on Tuesday morning?
Due Wednesday. So you,
Usually.
and Monday will be kind of like, I'll do a little introduction on those topics.
Yeah.
So we'll have some flexibility.
Can we just do a review?
did these cancel out?
So
Yeah, it's-
we can talk, we can talk. We'll talk. I need to cover that material, right? I need to cover beams, start covering beams on Monday. Yeah. But we can also go through other kind of. I think we're on pace. Right now we're on a good pace to finish all the material that we've been wanting to cover.
So do we need to download?
Okay, so yeah, we talked about this a little bit. For which one?
I'm about to start.
9 versus 8. Okay, so if you go, no, so if you go up.
Yeah, those are like I need to download
Oh, yeah, so yeah, you can go that way, yeah.
Do I need to download free?
It depends, if you have a CAD program that you like, or down to then no, but it's, screen CAD is what you use.
Screenshots.
Screenshots need to come from FreeComat, so I need to download both. If you're gonna do it all on your computer, you don't already have it, because FreeCAD is what we use to create the geometry, so FreeComat is what we use to do the finite element analysis. And it's kind of a, this is a,
No, there's no 2.
unwieldy but common workflow in industry, where you have a CAD program where you're doing the work, and then you're looking at the finite element and something else. That said, of course, FreeCAD actually does have finite element. SolidWorks has it.
They should put.
Better. But the screenshots need to come from the FreeComat. Where's my mouse? Bless you.
Thank you.
Wait, no, it's only. That's it. Seven labs.
Oh, yeah.
Bro, I didn't know that. I didn't know that's not bad.
You guys take
In Charlotte?
I heard it was really good.
He's like 2 months older.
Yeah, he's the one that like you're trying to get.
Yeah. He graduates in like that, so you have to get like 4 objectives. Like, basically, like, there's like 11, how many 4 objectives are there again? Yeah, there's 11 core objectives. And you have to get all the objectives right at least 2 times. If you get them right 2 times, you never have to do them again. So every test is the exact same. Yeah, like the first test is like 4 objectives. Next test he has to like add a couple more. Next test he has.
Not like that. How?
Wait, what?
I say it help us.
What do you mean? Yeah, I do anything wrong.
Knock out 5 next semester. Are you taking God cards? Are you taking the first? I'm taking that.
Well, the interval is done, it's gonna be so.
You define your X, define your Y. Yeah, plot X, Y. What is it you need, like, line of text? That we never had it. Yeah, probably like define the best fit and just add that to the plot.
Mechanics and materials properties.
Because that's the thing, like, so. Oh, yeah, he's where he's the next guy. It's the last of his time.
Like, I'm gonna take the spring class.
Excel's also really good for modeling. You can model? No, that's more for finance. Oh. Well, you couldn't do that, so like, you know.
But this was the only class.
Yeah. I think it was for a macroeconomics class.
What's it called?
Maybe we did that.
What's it called? Materials and
Whole
properties.
like budgeting, like have a
Oh,
lot
I
of
would take
like,
spring
do
semester.
all equation setup, so just plug in like whatever budgeting was. You do your thing and it would calculate how much it is. Yeah, that's what they get DC down. For like macroeconomics equation, I was like, this country is like, for some reason, how it is. Advanced. And then we
Alright, so
like,
that is
push
already.
shit.
And I was taking design.
Yeah, I did.
No, and I'm taking CAD as well.
Yeah.
Classes.
So you're looking at
6
Yeah, about 6.
So you got this one.
I'm not in the back for sure.
Thermal, DMC, measurements, calc. We got this.
I saw that.
Oh, yeah, like,
Sure, you see
Yeah,
thermal.
Dude, there's no other option. There's literally no other option.
Man's gonna wake up to thermal.
Yeah.
Dude, it's at 8:30.
They want us for taxing, yeah.
I always wait for this thing. Dude, like, like you guys get here so late, so you guys want to buy. I can like 10 minutes. You guys are here.
Dude, my restaurant is like, I'm not gonna I always get an M for
Oh, for real?
For one class.
Actually, it's just like, yeah, but I didn't really, you got Charlie? No, I just don't know. Yeah, I don't know Charles. Yeah. Oh, that's why I think it's
Yeah, what we do is like if it's a slow day, and we do really like pack, then we'll take on second. Yeah. So when you have like an overall percentage, like applications that I want, which is fair, I used to be this app, so like.
So you're doing envelope SCX and you're doing outside. But then when you click in zeros, they're still in channel.
Yeah.
Thanks.
Well, I also have definitely some actually do. I just put this into it.
Alright, so what are your units? So.
Oh, yes, it is.
Well,
They're
one
in
in
the
the
morning.
morning, two in the morning.
You're not going home till like 2 in the morning.
Yeah, that's what I have. Is it not solved from 0 to over 2 or?
Dude, that's always.
Well, what the heck?
So
Yeah,
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 you
yeah.
go zero, no, close to zero, you get up to zero, right? Take like an L over two.
It's like a message is a
Yo,
comment.
they always.
Are you private?
No. Yeah, I see a lot of UDF.
Yeah,
I
I
was
see.
thinking you could just
Key is the other.
Kilograms per meter cubed.
How do you turn that over?
Can you push this? I can take it.
Hold on, I do know that. Now you can see what the average rate is.
grab right here.
I know where it's at. Did you do kitchen? People, is your work kitchen?
Yeah. I started out as a beginning, was very much
Centimeters squared.
the absolute worst job. Okay.
And so. Maybe it's doing it wrong.
Yeah. You know, ours was not that organized. You guys have, we were like, you just hear someone yell at you. You're there like the first hour watching. Yes, oh my god. Yeah.
Is it rapid seconds?
I'm gonna say a 40 minutes time.
in the middle, but you download it.
Yeah.
Yeah.
Like,
So we're looking for the.
I'll show you, like, when I go through it.
Oh, so was I not supposed to be manager?
Oh, look.
The worst day.
How do we just figure it out?
Oh, I thought we had to, so is it just
It's just.
Yahweh to just this?
I wouldn't tweet it because you might use that for the next one.
I did both hearts in the problem.
Yeah, you jumped to the next one, that's why. Sorry about that, but yeah, I was like,
Well, okay, I'm
yeah, you're gonna do exactly what you just did for the next problem.
okay, I'm happy.
Ow.
Easy as.
Oh, yeah.
Yeah, but they're building it. Yeah,
I got that. Oh, wait.
Yes, 1 minute.
You mark the absent.
Today?
I got it before you.
Oh, I did.
The managers again, the rest of them like, no, we'll figure it out.
I don't know.
No, if you read. You don't type it. Okay, yeah, we have the exact same setup.
So what was the, what did you do? What's your number?
That was, what is it?
No, it's probably like, I don't know, industrial, slightly better, slightly.
Wow, that worked.
Yeah, you're getting like feeling super.
No, but then I multiply.
Because except we carry like. Yes. Dude,
Oh, so you had row.
Yes. No one else. They're only 16-year-olds.
Really? I'm sorry. Which one?
I don't know, it just shows out at 97. It was another day that you marked.
Well, I don't know how. That's a peculiar thing. How you could have.
Oh, and the range is.
How could you have a night? We haven't had that many days
It says 97 out of 100.
for attendance.
Yeah.
Let me take a look.
Yeah.
So that's your. Okay. So first though. Okay. Yeah. What's up with this?
When you press the
We
board.
can figure it out. We can figure it out.
Well, first time to extract this.
Oh, okay, yeah.
Yeah,
no,
this is the work.
I just pressed the run anyway, and it popped up.
Oh, it worked?
Yeah, it's just, they're bound.
Oh,
When you use drinks, you do like this, right?
so for the first day, did I act? Oh, I don't think I knew how to do it the first day. So I put people as yellow, but I don't do that. Let me fix that. Let me fix that. Or maybe that's probably what it probably marked you as late. So I stopped doing that though. So let me fix that. Let's see. So that the first day was on the
Oh, and I'll carry like sometimes I'll carry like
The first day was on the
this is
31st. It's not 30.
Wait, this is stage house.
Thursday, June 8th. Oh no, that's today.
There's also
What?
There's also a cool backside.
I'm sorry. Hold on. Let me make sure I got this right.
This is the inside.
Thank you for your patience.
And there's upstairs.
I'm learning how we do this. Okay, so this. Now you have a green arrow.
Oh yeah,
Did it change it? Are we all good? Sorry about that. That's just me. I'm glad you guys are on top of it.
Yes. That reminds me. So this is, little thing. But for the first session, remember those first couple questions that were just for fun?
Yeah.
Did you just not grade them yet?
Yeah, well, they're worth zero.
Oh, they were worth zero. Okay,
They're worth zero.
Okay, I didn't get that. Okay.
Are we good?
Yeah.
Keep up. Keep me honest, guys. Keep me honest. It's good.
And then band on Thursday, and so that's the best part. Oh, yeah, so you get to walk around. Yeah, the guy gets close. It is so. A lot of my stuff communities, and they're just so funny.
And especially when playing the snake, how you play the snake.
Yeah, I know the read up the joke.
Yeah.
When they come in on the outside, one girl's happy, she's a fashion star or something.
For us, we just get like the worst thing for Christmas time.
Oh my god, yeah, that is a Christmas last year.
Like they paint all the roof in the house, but it might be silly. Every 5 minutes, that would be. I really see that.
Okay.
Just a quick question about units.
Sure.
So I'm doing this problem where I'm trying to find the change in length of a vertical bar due to gravity.
Yeah.
So it's density times gravity, length squared divided by 2, elastis
Yeah.
modular.
Yeah.
And I just did out the units to try to figure it out. So it's density kg meters cubed, meters per second squared, times meters divided meters squared. Oh. Okay.
Yeah.
So Does that help though? So if you know meters, so I have kg divided by seconds squared GPA, so
Okay, so then
pascals. Does
Pascals.
that convert to
it should.
meters?
It should. It should.
How?
Well, pascals, right, are going to be 2
Oh,
millimeters per
so
second squared,
Oh, okay.
divided by area,
Okay,
right?
makes sense. Okay.
Yeah. Well, I don't know if it makes sense. That was fast, but yes, it should. Okay.
I just forgot the square.
Yeah, it's tough to keep them all straight, right?
Yeah, you just gotta do it out.
That is just, yeah. It's omega L6. That's a discrete omega squared. That's what
It sounded right. So I got the full weight of it would be who was opposed.
Yeah, I did expo. Expo is the worst job. So an expo is like, so you have the kitchen, right, the chefs, and the chefs will put up the food, right? And then like, what are the expos?
Oh, wait.
You're the middleman between the chefs.
Where's the lines? It's just
So,
going.
I get you have tickets in your kitchen.
Bro.
Tickets get printed out. So you get yeah, or a TV screen. You see TV screen, like also next right up. And once it's ready, then I get the receipt.
What was the
And I
egg?
have to organize that. So I put garnishes, like finishes, whatever, and I send it to the workers. It's a really stressful job. It's just one expo, and then you have like the workers. Then you're like, I need fries. I need 5 minutes to make fries. I'm like 2 minutes. And food's getting cold, and you're like, this shit freezes. It's the most stressful thing by far.
I was considering one to do a show with the bar.
No, that was, it's the most humbling thing to eat. It is. Everyone, yes, everyone absolutely. Yeah,
They should,
yeah.
either retail or restaurant, they have to do.
Yeah, you'll become like the best. It's underrated. Like I love like, I was like, I'm not really sure it's my life.
I remember the formula you had for, remember the formula you had for the first question, it's just row.
Yeah,
X. That's just what.
Or you can, because they're like, it's in like 5%.
So as your cancel out. So now I have no idea why.
What was this one? I don't remember. I know that thing at least. No, my friends do like do that. Like 10% tip. They won't like know that nicer. He's like, you should just like this sort of quick. Yeah, you just stack your stats pretty much. Yeah, because then the imposter's gonna come. I'm like,
Oh, is it the
exactly, yeah. No, I did it like my friends are doing like 4, and then now like the
Oh, they put the plate in the
Yeah.
forks on that, and then on the plate.
you take
Yeah, everything was.
and the trash can. Trash, forks, fish cans, and trash.
That's actually more ideal.
Oh, yeah, you take the bus and he's like, this makes it so yeah. And the worst is when the table kind of pile they made, so that's a nice gesture, but it's like, that's sweet.
What I learned from retail was like, basically, if you ever learn to find an on thing, it's really good everything.
Yeah.
So you find, even like, or like, oh, this is your daughter, sorry, but it was like, I feel like that was not, she's a manager. We're gonna call it.
No, food is
I wanted to like, I just like to remember my sister, she like,
pizzeria, bar, tavern, stayed up for a bit, and then she left. Smaller town apartment. I've stayed as but also I don't contract, but also I work in the kitchen.
Oh, okay.
So you guys refrigerators have ice makers. I've seen ice makers actually. Their ice makers are. You know, this is the ice is like a little cloudy.
What do you mean? I was just confused.
Oh, well, yeah, it's like cloudy. All the ice got his line cut everything.
Yeah, it's to spend over 12 hours. You get anything free.
I get like, I'm starting to do like, when I get ice down, I'm just like put my head in. Oh, God.
All right.
That sounds surprising. This is two trials, this is two trials. Yeah. No, this, two, five. I think that was the height. No, I'm good. I don't know if I have.
So, Professor, for this, exam on Tuesday, it's session 1 through 10. Are we allowed a format sheet?
Yeah, you can have one sheet of anything you want, front and back.
Yeah, that's slope. That's slope is right. So that's the same as that, yes.
And it's, you said 120 minutes? How long?
It's going to be that you have as much time as the whole class.
Do you know how many questions?
No.
No? Okay, fair enough.
Oh, I see what you're stupid. Okay, so you can't just use L, you have to take the derivative.
Yeah, people are coming for me, I'm like, yes,
And when you do that, obviously, L, which means you have to take the function and plug L into it, not plug X into it, plug. You have to plug L into this formula, which is equal to 1/2. So you get what we had in the square. I can minus 1/2 L squared, which is 1/2 L squared.
honestly, that's how we sell stuff to right too.
So this derivative of this, or is this the original first formula?
I just want to let you know, so for measurements, 4x4 is 2 is not actually like a little wood shop. They come off the lumberyard, but they're not, they sell for but it's like.
Wait, what's the voice that you're using for your friend? No. Oh, okay. I was just figuring out
That's a good question. Yeah.
Okay, so, since it's attaching to the max, yeah.
Okay,
To 0, but this is just the
Yeah,
original.
yeah.
So that's just rho A squared.
Oh, it's not, yeah.
Yes. Is equal to 0, and if you solve this for x, you get x is equal to L, so that means that L is the maximum. But you can't just plug x into 0, you have to take this
Have you been to Utah?
plug it back into this.
Yeah,
X
I have a lot of friends.
L, rho A minus squared.
that's just like, just like, my friend, he's the manager for the hockey team. Qualities, same thing for the manager. If you go, usually they have like a group hockey, I think it's probably like one there.
The main thing.
Yeah, I'd probably say.
I've been to New York, I've been like sucking.
So they would need to.
Like the formula.
Guys are doing a lot.
No, he's the manager. He's the guy. No, he's the that's it.
Why do you have points? Where you? Yeah, the air is awesome.
Yeah.
Cancel out.
And you're just going through it, yeah. Just like it has, wipe them out, yeah. I don't know, those guys are hilarious. Yeah. Yeah, have you ever been to college? At my last university, you wear like a student game. So we'd all, we'd all, it was just like, they're D2, so it wasn't crazy, but it was still worth it. It was just watching the dudes. Yeah, it is, man. It's the best.
Yeah, they were
I
good.
mean, you're only there for like, that's amazing.
I know the first flight I remember this morning at the very bathroom. Dude, I left my house at 9.
Yeah, of course.
I got here at 11:10.
Oh yeah, if you think all it's the unspoken.
You're gonna get bodies.
Yeah, no, everyone's gonna come. That's what he's talking about. I mean, I think it wasn't like I don't watch it.
No, yeah. Like football, like hockey.
Yeah. No, it's the same concept. It's like-
All right, so I hope you're doing well. I do want to just go over one or two things on Torsion. All right, so we talked about session 9 at the beginning of class. That was labeled Torsion 1, and then session 10, which is the last session that would have material covered for the exam, is going to go into further depth and give us some perspective on angle of twist. Okay, so in session 9, what we discussed was how we can figure out what the shear strain and the shear stress are along a rod that's being twisted with a torque. Okay, session 10 discusses how we calculate out what the actual amount of radians of twist might be, okay, with the applied torque, right? So this is intuitive, but you want to go through it. And there's some very tricky problems in there, and so highly suggest that you go through them. And one of these problems that can be deceptively tricky, okay, is, and as you go through it, you'll be able to find this information, all right? But one problem that is analogous to a distributed force acting along a bar to extend it is having a distributed torque acting along it. All right, so what am I talking about? And even without even without having done this problem, okay, we can do equilibrium, we can think about it. All right, so what we have, normally you have like a torque, say at the end, that you're applying to this rod, and that's what we use for angular displacement or angle of twist. Okay, in this case, we have a distributed torque. Okay, imagine Jumbo the elephant's trunk holding this rod and applying kind of this nice distributed force, distributed torque, along it. Okay, and this distributed torque, remember, well, what are the units of distributed force? Newtons per meter, right? So what do you think right? What are the units for distributed torque? They're going to be Newton meters per meter. So it's actually kind of funny that the distributed torsional load or distributed torque can have units of newtons, okay, because it's Newton meters divided by meters. Anyway, so that can be given by a lowercase t, and you can see that it's being applied here, right, around. Now, with this distributed torque, right, what you see is that just like you have with a distributed force, there's going to be no internal torque at the right end. Remember how when we have gravity acting on a hanging bar, there's no internal force at the right end because there's no material there for it to act on. Similar thing here. But all the summation, right, or all this distributed torque integrated up, just like mg, right, for a bar that's hanging, that's all going to be supported by the wall. Okay, so there's a reaction torque at this wall that's given like this. Okay, that's opposing this, and then we do external equilibrium to figure out what that reaction torque is. Now, this reaction torque is going to have units of Newton meters, not meters, or not newtons, or not Newton meters per meter, right? So here is the external equilibrium, and this is the key thing, okay, or one of the key things. It's going to be T times L. So just like you can figure out a force, right, by integrating a distributed force, dx, right, integral of lowercase f dx, right, is equal to that torque, or equal to that force, sorry. The external, the torque similarly can be thought of as TL. That's the integral, right? So this TL, maybe I'll just write it out. TL, right? That was what we had as the integral of TZ from 0 to, TdZ, right? Like that. Anyway, so that's this torque. And then I have the reaction torque, okay? And so I can solve for the reaction torque, and it's just TL. Right, so not a big deal. But now, if I do the internal equilibrium, when I take a slice, all right, and let's say I take a slice right over here, I have the internal torque here, and I'm following the convention where Z is positive, so this is following the right-hand rule, okay? And I have my little t still acting over some segment, and we have our reaction TR still. Okay, so now we have to do internal equilibrium, right? And if we add all these up, well, we say, well, we have a TZ, right, going back to this thing, right? So I would have, right, TZ is integral from 0 to Z of T dz, right? That's just giving us what is the length of this segment. What is the length of this segment here? TR is the reaction, which I already solved, is TL, and TI is an internal torque, right? On that slice, following the right-hand rule. So TZ plus TI minus TR, because I'm using this convention here, or using this direction. So that's opposite. So I get the internal torque is equal to the internal torque Ti is equal to TR minus TZ, and it's equal to this, T quantity L minus Z. This is a subtle and important thing to keep in mind, okay? Because remember how we said integral of P over EA dx, right? So we have the analog to a bar is, if I want displacement, right, I can do the integral of P over EA dx, right? That's for normal loading. So you'll see in the notes, and it's derived, that we have an analog where we have the integral of torque, and this is a function of z, all right, over a jg, right, shear modulus, and we already talked about the polar moment of inertia at the beginning of class. So it's analogous to the bar, and so what we had to do is we had to plug in the internal torque that we solved for here, and we then do this integral, and we get this result. Okay. Now, in the previous video that you might be looking at when you do this, I kind of shortcutted it. All right. I did it this way, and this is technically still giving you the same answer, but it's glossing over a lot of the details, and it's doing the integral really from here to here. It's not really setting up the integral quite right, even though the answer is correct. Okay, so as you study distributed torsional loading, take a look at this more careful approach, and I'll upload the modified slides. I mean, it'll be up there, and there will be a note also I'll put under the video saying, there's the summer session has a more careful approach to being able to solve this out. Okay. One thing to also note is that this torsional load, this distributed torsional load, is constant here, right? But it doesn't necessarily have to be, right? We've had distributed forces that are not constant as well, and so that can be kind of a little extra difficulty but for now, this is the approach we want to use to being able to calculate the angle of twist for essentially for a rod that has an internal torque, whether it's from distributed load, whether it's from a concentrated load, whether it's from a varying load, right? This is the formula that we can use when we do the integration. Any questions? Okay, just wanted to point that out. Yes?
So when you have little t, that's for distributed torque.
Right, just like little f is for the distributed force, right? And again, one of the key things here is that this P is an internal force. This Ti, right, that's an internal torque, right? Remember we said you got to use the internal one when you're doing these displacements. Okay, so the same thing applies here. Good. All right. Well, I'm going to save this and I'm going to upload it.